Hello everyone, this is Professor Iris Miano covering the first three sections in Chapter 2. This is an ambitious amount of material to cover, and there's going to be a lot of new terminology coming our way, so a lot of writing down definitions, so prepare yourself for that. Furthermore, these are the first three sections of the new unit. This is Unit 3 material that we will be starting here. Just to be clear. Okay, so let's go ahead and dive right in. And while we have been mostly focusing on algebraic topics so far this semester, we are now going to be diving into actual statistical concepts. Okay, so this will definitely be super relevant to your next course, Math 54, if you're taking it here at SMC, which is Introductory Statistics. This is your first taste in this class, at least for these statistical concepts. So here we go. Let's start off by defining three very important fundamental terms, and they are individuals, variable, and observations. Okay, so what is an individual in terms of statistical studies? Individuals are the people or objects we want to learn about. So let's go ahead and add some notes. The people or objects we want to learn about. Then let's go ahead and define what a variable is. A variable is a characteristic of the individuals to be measured or observed. So character of the individuals. To be measured or observed. Don't seem to be giving myself enough room to write the definitions the way that my penmanship allows, so there's a little bit of a spillover. One thing to know about variables is there could be more than one involved in the statistical study, and the observations are defined as the data, basically. Collected. Data collected, we'll say. All right. So let's consider a particular example. Now, this is a bit of information from a statistical study involving movie studios and their worldwide gross receipts, or U.S. gross receipts. So this is just, the amount of money made for 1, 2, 3, 4 particular movies. And we want to take a look at this information in the table and then answer the questions here, identifying individuals, variables, and the observations for each variable. Okay, so the individuals here are the movies. Okay, so go back to the definition. People are objects we want to learn about. Okay, so they would be the movies for this particular cache of information. So the individuals are the movies. And we can list them if we want to. Avatar, Titanic, Marvel's The Avengers, and Frozen. Okay, the variables. What are the variables? Now there are three different variables here, and I'll maybe change up the color here. There'll be studio, worldwide gross receipts, and U.S. gross receipts. So those are the variables. Let me go ahead. So those are the the things, the measurable items, characteristics, right, of the individuals measured or observed. the variables are studio, worldwide, gross receipts, before E except after C, and US gross receipts. I always forget that rule. So for each variable, there are observations, and that is the information in the chart proper. Okay, where okay, so just as a recap, the individuals are these row identifiers, these row headers. The column headers, other than movie, of course, are the variables, and then all of the meat inside of the sandwich are the observations. So for depending on the variable, you could have qualitative observations, the name of the studio, or you could have quantitative observations, which are going to be these millions of dollars gross receipts, either for the worldwide or the US. So let's get a different color going. So these right here, and separate them into the different piles. These are your different observations for each variable. So for studio, I'm just going to go ahead and point to those ones, just because writing them out would be incredibly cumbersome and time consuming. So the worldwide gross receipts, spelled it right that time, that'll be this collection of numbers, and the US gross receipts. Almost spelled it wrong that time too. That'll be this collection of numbers in this group. Okay, cool. So what have we done here? We've defined some very fundamental statistical study terms, and we were able to identify them in this very simple example. Okay, so there are some procedures that we want to outline here as far as like what a statistical study is, like what the practice of statistics is. The first thing you want to do is raise a precise question about at least one variable, but there could be more, as you saw in that first example. And then you want to create a plan to answer the question, collect the data, analyze the data, draw the conclusion. Okay, so these things are more or less going to be something that we are going to read about and analyze. We'll analyze some data that's already been collected. You're not going to be collecting a data or even asking your own questions in this class. We're still very much in learning mode when it comes to statistical studies. We're just going to see what others have done before us, and to get a sense of what kinds of possible design mechanisms there are for studies. We're in the observing already completed studies and learning about them mode. So you're not going to be creating your own studies in this class. Definitely in Math 54, there's going to be, I want to say, at least some sort of project element where you formulate your own question and you structure your own statistical endeavor. Or you do it in a small group, depending on how your instructor wants to do it. But in any event, we need to define some more terms and dive a little deeper into some examples. So the next term that we want to define is going to be population. Okay, so that will be defined right about here. This is the entire group of individuals about which we want to learn. Entire group of, what's P, individuals in question. I'll say, I'm going to just modify my definition so slightly so it just fits on the one line there. And then within an entire population of some group, you can have what's called a sample, and that is just a part of the population. it is often impossible to say anything definitive about an entire population, although you want to draw some inferences from time to time using statistical studies, and so taking a sample is one way in order to do that. And the way that you take your sample and what you do with your sample, well, that opens up a whole, discipline, basically, within the exercise of statistics. Now, this next term that we want to define is census, and it is when you take a census, you are taking data on all members of the population. So, data collected on all members of a population. Let me erase just a little bit. Oops. Here. Can you just do the eraser thing? Okay, let's just rewrite the word members, I guess. Members. Okay, that's much better. All right, let's read the following example involving Labrador retrievers. I'll read it out loud to you. Researchers want to find out how a restricted diet would affect a Labrador retriever's lifespan. Of 48 Labrador retrievers being observed, 24 were fed a normal diet and 24 were fed a restricted diet. The dogs' lifetimes were recorded. The study concluded that a typical Labrador retriever on a restricted diet tends to live longer than a typical Labrador retriever on a normal diet. Okay, and then the source is given there. I'll go ahead and not read that one out loud. Okay, so what is the question that the researchers are trying to answer? So for this one, I'm going to actually go for the highlighter because I think that'll be more fun. So what is the question the researchers are trying to answer? Well, they want to see how a restricted diet would affect Labrador retrievers' lifespan. So I'm going to go ahead and write that down. How does a restricted diet affect a Labrador retriever's lifespan? And often you will find the question very early on in the description of the study. Usually it's in the first sentence. That's not always the case, but certainly the case here, and it's often the case. Okay, define a variable in the study. Okay. Well, the lifespan is going to be a variable in the study, right? The individual dogs are going to have what kind of things recorded. Well, the lifespan is going to be recorded. Let me go ahead and change up the lifetimes were recorded. So we'll say that this a variable is lifespan. Okay. And just a moment. Sorry, I need to press pause for just a second. There we go. Sorry for the interruption. I just had to answer a text message. That was time sensitive. Another variable that I wanted to mention was, of course, the diet. Now, I know in the problem here it just says define a variable, but for, just being very thorough, I thought I would also invite another one, is the diet. Either it's restricted or it's a normal diet, right? Is the diet. Okay, identify the population. Now, the population in the study is all Labrador retrievers. Well, the sample is going to be just the 48 that are right here. All Labrador retrievers make up the population. Oh, another thing I wanted to do was to talk about variable in the study. It's lifespan, lives reported, and then also the diet is in there as well. Okay, cool. Now, the sample, we'll do that in another color, green highlighter. They gave us an indication of the sample, right? And it's going to be the 48 Labrador retrievers in the study, okay? So the sample includes 48 Labrador retrievers in the study, or you could just say labs for short, in the study. Take away that comma. Great. Okay. So let me know if you have any questions about that. Let's define some more terms and then talk about some more examples here. Now, there is different kinds of statistics that can be analyzed here, and so we want to make the distinction between these two distinct types. There is descriptive statistics, which is the practice of using tables, graphs, calculations about a sample to draw a conclusion about only the sample. So let me go ahead and write some of that down. Yeah, we'll keep this color here. Use tables, graphs, calculations. About a sample to draw conclusions about the sample. That's probably the most important part of this definition here. Use tables, graphs, and calculations about a sample to conclude only about the sample. Whereas inferential statistics is the practice of using information from a sample to draw conclusions about an entire population. So I'm saying using information about a sample to draw conclusions about an entire population. Okay, so for the Labrador study, what was the conclusion, or was the conclusion a part of descriptive or inferential statistics? Let's go back to this and take a look. Now, certainly there was a sample involved, the 48 Labrador retrievers. Now, what was their conclusion? The study concluded that a typical Labrador retriever on a restricted diet tends to live longer than a typical Labrador retriever on a normal diet. Using this language, typical Labrador retriever, we're supposed to be making conclusions about any Labrador retriever. So from that, we can glean that the study is part of inferential statistics. So the study is part of inferential statistics. If it was descriptive statistics, they would have said in their conclusion that we were only concluding this about, the 48 dogs, but that wasn't the language that they used in their results there. So let's look at number 2 now. Researchers surveyed parents with college-bound teenagers ages 16 to 18 years, asking whether the parents will limit their children's choice of college based on cost. Of 1,000 randomly selected individuals, 48% said yes. Define the variable of the study. Okay, so a variable of the study is if parents will limit their children's choice. It's like based on cost. Either they will or they won't, right? So, so how do we want to write this? Hold on. Asking whether parents will limit their children's choice of college based on cost. Kind of a mouthful here. Okay. So the 1,000 randomly selected individuals, that is the sample, okay? Let's go ahead and do that. Oops, let's go back here. 1,000 randomly selected individuals. Is the sample. The population is going to be all parents with college-bound teenagers. I'll go ahead and highlight that as well. Yep. Oh, let's do this so we can highlight it there. Okay, the population is all parents with college-bound teenagers ages 16 to 18. Whew, quite a long description there. Identify the conclusion and determine if it's part of descriptive or inferential statistics. 48% of parents surveyed said they will limit the children's choice of college based on cost. And this is part of, well, what do you think? We're just talking about the 48% of parents surveyed, right? So since the conclusion is based only on the sample, this is descriptive statistics, okay? So we'll say this is part of descriptive. Hold up. Descriptive statistics. Okay. Great. More things to define. But we're just going to define these 3 things and then we'll be done with this 2.1 section. They will definitely be coming about again in the next section where we're going to be talking about different types of sampling methods. Okay, so let's just define them and then go on to the next thing. Simple random sampling is defined as the process of selecting a sample of size n if every sample of size n has the same chance of being chosen. And furthermore, a sample selected by such a process possible. Okay, yeah. So I'm just reading out of the textbook, as you can probably discern. How do I want to reword this? Process of selecting a sample of size n. Where n is just some natural number. Where every possible sample has the same chance of being selected. And since I'm a little wordy with my definition there, I'm going to go ahead and change the color so you can distinguish this definition for simple random sampling versus sampling error, which is defined as the error involved in using a sample to estimate information about a population due to randomness in the sample. Okay, so the error involved in using a sample to estimate information about a population. Due to randomness in the sample. Okay, so sampling error can only really occur when we're doing inferential statistics, since, we're just trying to conclude something about a sample, then there's not going to be any sampling error because you're just trying to conclude something about the small group that you have collected data upon. Okay, I'm going to change the color scheme yet again to something distinct. Let's go this dark green color. And define bias, a sampling method that consistently underemphasizes or overemphasizes some characteristic or characteristics in the population is said to be biased. So, a characteristic. So bias is a characteristic of a sampling method. That over or under emphasizes some characteristic or characteristics. Okay, in the next section, we're going to get deep into very specific types of sampling methods, and we're going to have an example of each presented, and we'll be able to, having a full understanding, hopefully, of each sampling method. It's going to be defined on the sheet itself. We'll be able to identify these different sampling methods in the examples presented. So that's what we're going to do in this next little bit right here. Okay, so now we're on section 2.2. And notice that there are 5 different sampling methods defined here. And so I'll read each 5 of them out loud for you, and then we're going to identify the sampling method for each of the 5 examples presented underneath. Okay, so first let's define simple random sampling, which we did define earlier just a second ago at the end of 2.1, which is redefined here. Every individual in the population has an equal chance of being selected, far more concise than what I presented straight from the textbook. And then the next type of sampling method is called convenience sampling. And this one is the one that has the most biased, spoiler alert on that one. And it is defined as gathering data that is easy to collect and do not bother to collect it randomly, okay? Systemic sampling is going to be randomly selecting an individual out of the first K individuals and also select every Kth individual after the first selected individual. Now, having K and Kth, like this K and this K necessarily being exactly the same value is not indicative of this type of sampling. It just means that you are choosing some number of individuals to pass by before you select the next one in your study. And you could continue on that particular pattern, or you could slightly adjust the pattern just so long as there is a pattern afterward. Okay, so this K, just to be clear, let's add some notes. This K and this K might not necessarily be the same, is all I'm saying. And I mention that just because I remember there being an example in which they're different, but it's still systemic sampling, okay? Did I say systematic? Oh, it's systematic, yes, is the name of it, but this is a typo here. Actually, I need to address this typo before we get too deep into this biz. So this is not actually the way it's written here. I just remember this. Sorry about this, guys. It's systemic. Or sorry, it's systematic. LOL. Okay, systematic is the describer there for that type of sampling. Okay, so hopefully that's not too jarring. Let's go ahead and talk about stratified sampling. That's when a population is divided into subgroups called strata. Very fun word right there. In each stratum, which is the individual or singular of strata, the individuals share some characteristic. Some random sampling is performed on each stratum, and the ratios of the number of individuals randomly selected are equal to the ratios of the stratum sizes. So stratified sampling is most easily confused with the next one that I'm going to describe, cluster sampling, which is a population divided into subgroups called clusters. And we simply, you do simple random sampling to select some of the clusters. All the individuals in the selected clusters are used in the sample. Okay, so as far as being able to distinguish this one from this one, I have a couple of different ways to identify what's going on here. Okay, so for stratified sampling, I'm going to just put a little bit of a picture off to the side here. So we have a population. Okay, population. So that's for this one here. And it's divided into subgroups called strata. So let's say we have 4 strata, okay? And that's what these little circles are right here. So, and then there's individuals in each group right here. So let's have the individuals be this pink color, okay? 2, 3, 4, 5, 6. 1, 2, 3, 4. And so I want you to notice that the number of dots that you see in these slightly larger strata is going to be more than the slightly smaller strata. You'll have fewer dots and fewer dots. Okay, so the ratios in the number of individuals randomly selected are equal to the ratios of the stratum sizes. So let's let green going to be, that's going to be the people that are associated with the actual sampling. Okay, so let's say I take about half of each strata. Okay, So those are going to be the people that are in the sample. Okay. Whereas if for this one, the cluster, you still have a population, and you have clusters this time, and let's say they're exactly the same, okay? But the strata being the same as the clusters between the two individuals. But I'll show you how this sample gets to be different. So how many dots did we have here? I had 3 in that one, 4 in that one, 5 or 6. Here we go, whatever. Okay, so the way that this is different for the cluster sampling is that the sample is going to be entire clusters. So let's say we sampled this entire cluster and this one, okay? That will be the sample there, okay? Cool. Whereas we took ratios, the same ratios of each individual strata or grouping for the stratified sampling, okay? We took half of them here, half there, half there, half there. Where for the cluster, you just take a cluster and a cluster, randomly selected the clusters, okay? So hopefully those little visuals give us a better idea of what's going on there. Keep all of these definitions in mind. And yeah, and I'll go ahead and put a note that these are the easiest ones to confuse. Okay, cool, but we'll take a look at this. All right, so here are 5 examples. We're going to identify whether the sampling method is simple, random, systematic, stratified, cluster, or convenience. There's one of each, okay, so no one type of sampling method is going to happen, you know, twice in this group, okay? So here's number 1. A researcher randomly selects the 73rd car fuel tank on an assembly line of every 100th fuel tank after that. Okay, so this is definitely super duper clear, hopefully, to everybody, a systematic sampling scenario. So the K and the K here are not the same number, but it doesn't matter. You are always taking a patterned approach in order to select the individuals for your study. So this is, and let me get a new, actually I want this magenta one. This is systematic sampling. So I'll just put systematic. Okay, so hopefully that makes sense to everybody, but let me know if you have questions about that first one. Number 2, to estimate the proportion of Americans who use Instagram, a Costco employee surveys employees who will work during her shift. That sounds incredibly convenient, right? For the data collector. So we're going to call this convenience sampling, okay? It's not random. We're just taking Costco shoppers, Costco employees, rather, not shoppers, co-workers for this particular statistician. So that's incredibly convenient. Okay, let's go ahead and look at number 3. A student writes the names of her classmates on slips of paper. Then she puts the slips in a hat, mixes them, and selects 5 of them without looking. That is simple random sampling right there. So just look at, yep, simple random. I guess we are going to what's the word I'm looking for? Assume that all of the pieces of paper are exactly the same size, so that way every individual has the equal opportunity of being selected there. Therein making it simple random. So the last 2 have to be, by process of elimination, either stratified or cluster. So this is where we have to really test ourselves on whether or not we understand the difference between these 2. Here's number 4. A wine grower divides her vineyard into 60 subsections, randomly selects 5 subsections, and measures the grape yields in those 5 sections. Yep, this is taking a random collection of the groups, the entire groups. So I would say that this is a cluster sampling scenario right here, okay? Cluster. You could, at this point, use process of elimination to determine that stratified has to be the last one there, but let's read through the example and make sure that we can convince ourselves that this is indeed a stratified sampling scenario. And number 5, in a study at Harvard, 24 students are randomly selected from African American freshmen, 40 students are randomly selected from Asian American freshmen, 26 students are randomly selected from Latino freshmen, 106 students are randomly selected from Caucasian freshmen, 2 students are randomly selected from Native American freshmen, and 2 students are randomly selected from Pacific Islander freshmen. Okay, so it seems to me like in this study, they are taking a proportional number of students from each a type of ethnicity involved in the study in order to conduct the study. So that to me says stratified, for sure. No doubt about it. Okay, so this is just a very brief overview of these kinds of sampling methods, and we matched them successfully to specific examples. So let me know what you have for questions on those, if any. Let's go ahead and jump into this last section where, yes, we have more terms to define and more examples of types of studies that we need to categorize and analyze to a very small extent. Okay, first let's define 2 different types of studies, experimental or observational, or if it's an experiment, we just call it that, an experiment. Okay, so an experiment, researchers determine which individuals are in the treatment groups and the control group, often by random assignment. So let me write that down for you. Let's add some notes. I like that color that we're currently on. In an experiment, researchers determine which individuals or who is in treatment groups and control group. So this is an and symbol right there. That's some shorthand for the word and. Often by using random assignment. I'll say often randomly. Whereas in an observational study, researchers do not determine which individuals are in the treatment groups and the control group. So researchers do not determine who is in treatment or control groups. Okay, let's read through this example study and determine, there's 2 of them, and determine if they are experimental studies or observational studies. Here's number 1. I'm going to read it out loud to you. Researchers wanted to determine the long-term effects of, the long-term benefits of the influenza vaccine on seniors aged 65 years and older. The researchers looked at records of over 36,000 seniors for 10 years. The seniors were divided into 2 groups. Group 1 were seniors who chose to get a flu vaccination shot, and Group 2 were seniors who chose not to get a flu vaccination shot. After observing the seniors for 10 years, it was determined that seniors who get flu shots are 27% less likely to be hospitalized for pneumonia or influenza and 48% less likely to die from pneumonia or influenza. Okay, so the fact that these seniors were divided into 2 groups, right? That means that this was an experiment, right? So, just a moment. Sorry, let me, I want to highlight this. Let's do the green. So they were divided into 2 groups, and yeah. So in that regard, we would say that this was an experiment. Okay. Number 2, xylitol has proven effective in preventing dental cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. Overall, the children preferred the milk flavored with xylitol. Okay, so for this one, it's an observational study. Now, why wouldn't it be an experimental study? Well, because in the study, all of the participants were given both treatments, right? Either the treatment or the control as well, and the groupings happened by virtue of the preferences by the children. So the children decided what group they were in, if they preferred the treatment versus the control substance, right? So in this case, it's an observational. Okay, study. Great. Just in the interest of time, I want to go ahead and move on. Get to the next definition. We need to define explanatory and response variables. So explanatory and response variables are connected, and that's why they're in a single definition box there. It's like the call and response of the statistical world. And we have in our previous knowledge associated with ordered pairs, points in a plane, tangible idea of what an explanatory and response variable could be in terms of x and y respectively. So explanatory variable is like x. It's a independent variable. Okay, and then the response variable is like y in the graphical sense. It's the dependent variable. Furthermore, something that I would want to note off to the side is that the explanatory variable may or may not turn out to affect the response variable. It feels like it should always have its effect. The explanatory variable should always affect the response variable. That's not always going to be the case. So I'm going to say off to the side, note the explanatory variable may or may not explain the response variable, or explain changes in the response, I guess is what I should say. Changes in the response variable. Cool. So something to note off to the side. Let's go ahead and define a couple of other terms: association and causality. So an association between explanatory and response variables can happen if the response variable changes as the explanatory variable changes. Okay, so can be seen, an association that is, can be seen if the explanatory variable changes oh, excuse me, I meant to say response variable changes first. My bad. Let me re-say this. Can be seen if the response variable changes as the explanatory variable changes. Okay, so remember, the explanatory variable is the thing that comes first in the scenario, okay? Like some action is taken, and then there may be a response after that. So if the response variable changes because of what was happening with the explanatory variable happening first, then we can say that there's an association, okay? So if the explanatory variable causes a change in the response variable, then we say that there's causality, okay? So let me go ahead and write that down. If, happens, causality happens if the change in the explanatory variable causes a change in the response. So it's true that with these types of variables in a study, okay, change can happen between the two variables at the same time, and that is association, okay? Now, if it is able to be determined that the change in the response variable was due to the change in the explanatory variable, then you have causality, okay? So, and a couple things to note about determining causality. A well-designed experiment can determine whether there is causality between an explanatory and response variables, and that most observational studies cannot determine whether there is causality between the explanatory and the response variables. They can only determine if there's association. So some things to keep in mind there. And we're going to get into some examples in a little bit with this. But first we got to define a couple more terms. My goodness, so many terms to define, but we're almost through with this section here, so hang tight. Now, what is a let's define confounding variable first. It's a variable other than the explanatory variable that causes or helps cause the response variable to change during the study. So a variable other than the explanatory variable that causes or helps cause change in the response variable. Change in the response. Whereas a lurking variable is a variable that causes both the explanatory and the response variables to change during the study. These are not things that we get into a lot of depth in this class, just to be clear. You'll get into a little bit more detail on this stuff, and it'll become more of a thing, like an issue, more of a thing that you care about in the next level class, just to be clear. But let's define lurking variable. A variable that causes both explanatory and response variables to change. Okay, so we have one last example to read through, and we're going to answer some questions about them. So here is the example. A researcher wants to determine whether watching television and playing video games causes attention deficit hyperactivity disorder, or ADHD, in children. The researcher randomly selects 200 children and asks their parents how much television their children watch daily and whether their children have ADHD. The researcher analyzes their responses, and it concludes that watching television and playing video games causes ADHD in children. Oh boy. So what are the explanatory and response variables? So explanatory that'll be the thing that comes first in the response. So we can kind of set it up this way. So what is coming first in as far as the things that are variables in this particular study? Well, it's going to be, right, the playing video games or watching television. It's going to be the explanatory watching TV and playing video games. Right? So those are the things that are coming first, because in the study they're trying to determine whether or not this causes or has as a result diagnoses of ADHD, or not necessarily diagnosis, but having ADHD. And in the next bit, they want us to identify a possible lurking or possible confounding variable. Now, lurking and confounding variables are more or less, they're defined as distinct things here, but it's okay if we think about them as kind of being a little bit of a wild card element, right? If we just kind of broad brush it that way, that is okay for our purposes here. So what do you think might be an underlying element that could be swaying this study one way or the other, right? They said that they believe that there's some causation here, right? That the watching TV and playing video games is causing the ADHD. Now, I don't know if you guys know much about ADHD. I don't know very much either, but I've heard an offhand report on NPR a couple of years ago that describe parents having ADHD. Their children will often have what's the phrase I'm looking for? Genetic predisposition to it. Okay, so a lurking or confounding variable could be parents own ADHD diagnoses, creating genetic predisposition. Another thing that I could think of is maybe parents are over-reporting or under-reporting how much TV and video games, right? Parents under or over reporting TV and video game viewing. Another thing is that, are these ADHD diagnoses actually being done by a medical professional, or are these self-diagnoses from parents? So these are the things that you want to think about in terms of lurking or confounding variables. Things that have nothing to do with the description of the study that you feel like might be having an influence. So parents doing a self-diagnosis, or I guess I'll call it an armchair diagnosis. That's actually the better term. Armchair diagnosis of their children. All right, so those are things that I feel like could be undermining the conclusion of this study. All right, great. So there's definitely lots of nuances to talk about with these first three sections because we're talking about more of the statistical end for the first time in this class of what's going on with statistical studies. So there is more discussion to be had about interpretation. So let's definitely spend some time having that discussion in class. Thank you so much for your attention.